Okay. Okay, is it coming across? Because I can't see the chat right now. And
Yes.
okay, so thank you, everyone. I'm here today to talk a little bit about what we've been up to in the medical devices working group. We're sort of continuing study along. We've got a regular group of people that sort of show up most weeks and have been advancing it slowly and surely, bit by bit, through this last year. So I'll be going through what we're actually focusing on right now, as well as a bit of background for those who aren't familiar with this use case. As I say, my name is Kate Stewart. I work at the Linux Foundation and I focus on dependable embedded systems, and obviously Linux is one of the key consideration areas. The vice chair for this group is Milan Lakami. He's been doing a lot of work on the SDPA analysis portions and helping us move stuff into tooling and into GitHub this year. So, but more details in a second. So for those who aren't familiar with this group, we've pretty much started right at the start in the sense that we were looking for Linux as a component in a system, and we needed to find some application when we first started this off that was open, and we suggested looking at the open APS. And we've been sort of continuing mostly with that ever since. We did a couple of divergences to look at ventilators, but we're pretty much stable on open APS. And continuing to advance technologies and methodologies with it. Reason we chose it, sources were available and no NDA was required to work with it. It's a hobbyist community, so the liability issue isn't there. That happens in other safety domains. And the community itself is willing to engage and explain things to us. And that was all part of why we ended up starting with that. And when we started to work with the ventilator, we decided we better should just call ourselves medical devices rather than just the open APS group. And none of us actually have diabetes on this group, except for one person who shows up from time to time who actually has it. But for the most part, most of us all are just interested in studying this as a problem space rather than something that directly connects to us. I'm actually playing around with a glucose monitor and things like that. And so seeing how some of that interacts with the studies we're doing is interesting to me on a personal level too. We're actually looking at, we actually did an investigation with 62304, and we actually looked at how the soup things are matching up with the open APS, and those results are available for those who are interested in understanding how this goes to some medical standards. And like I say, we've had steady progress for a couple of years now on this. So it's a familiar problem for us. The 62304 work was published a couple of years ago now, 2021. Actually, I think it was late 2021, 2022. And so we put out a report, and that is available. And anyone who's interested in understanding how that might work, it's up on GitHub. And if you read through it and you have feedback, we'd certainly like to, revisit it and start to, discuss it. But we're looking for feedback and information. Now, most of the work we've been focused on right now is using the system theoretic process analysis report. And it's a hazard analysis technique and looking at causation and why things are caused. And so there's an open book. Up again, we don't have to go to a public, we don't have to pay for a standard here to start making forward progress, which was important to the group, since most of us are looking at this from a hobbyist perspective. And anyone who can go and read the book and read the methodology, and there's lots of training material out there. And the reason we like this approach and we took it, it seems to be working, and other groups are now adopting it, is it's iterative. You work on diagrams so things become intuitive, as well as discussions. The handbook could guide us, and then we've been able to sort of get some of the feedback from the STPA community along the way. And so what is OpenAPS? Well, it's an artificial pancreas system. And the reason we studied was obviously the community and everything was open. There was a very good talk that got me inspired in this issue. A couple of years ago at the Linux Plumbers, it was actually the Linux Conference Australia, and Dana Lewis, who is one of the lead principals in this, basically gave a talk about it, and with the tag phrase of "we are not waiting," because the medical device industry was not giving them what they needed at the time, which was that loop. And there's alarm fatigue and a lot of other problems with working it. And so, in some of their work, they show some of these traces of the glucose and what's actually happening in the body. And the goal is to really get things to be leveled. And so your insulin is balancing with what your body is producing. And so you're not spiking out of the range, because that's when damage to your body occurs. So there's been more and more research studies happening over the last few years. And I've just put a link in here to one of the ones from the Diabetes Organization showing, this type of automated insulin is becoming safe and effective. And there were some other ones, papers published about, there's a Loop One as well as a few other systems that are open source that have been getting, acknowledged as being effective. And people are doing this as a hobbyist because it improves the quality of their life, rather than, trying to do it as a medical, a device for sale, which was lining up with what we were able to study then. So this is the first control diagram we came up with after multiple iterations. I think there's about 3 or 4 iterations that have happened as we kept on realizing there was another factor that had to be considered and brought into it. And it pretty much shows the interaction with the environment. And we ended up separating out, like, the human operator may not be the body that things are working on, because, there's cases where people are finding it beneficial to hook their kids that have type 1 diabetes up. And so the operator is not necessarily the 5-year-old kid, it's their parents. And we also have, the people who are doing the algorithm developers, maybe the operators, but we've got a wide variety of interactions going on. And we have, so this is an example of what the diagram would look like with the control actions and then the feedback information coming back. So various results are coming back. And, you request a glucose level to a device, and then you get it coming back, and that goes into the OpenAPS system. So after we sort of understood what was going on in the environment, we drilled down into the level 2 control diagram, which is really the system itself. And we sort of focused in on what was happening in OpenAPS and what was actually coming in and out between all the various devices around it. And since our focus in this working group is what's happening with the Linux portion, that's kind of why we sort of zoomed in on this direction. If you were focusing in on it from the algorithm side and so forth of what's running on your OpenAPS system, which is running on a Raspberry Pi with Linux, you might be doing more of a focus on that. But we're trying to focus on understanding how is Linux participating in this system, which is providing a platform for things to work forward with. And so, from a system view, there's a static side of it where you can sort of see how everything is hooked up. But then there's also the dynamic side in which subsystems are used. And for level 3, we really needed to start getting after what was happening on that dynamic side. How was the kernel being used? Because the kernel is such a large piece of software. We wanted to be able to start to focus on, what is OpenAPS using that's maybe potentially not just part of the regular core kernel. And so a big thank you to the OpenAPS community who helped give us some traces. They worked with us to provide traces, and then we worked through, Shua worked through with Shafali a methodology for creating how to do traces and work with them to get the information to them. And then we did some analysis on those traces that came back, because we wanted to understand which Linux kernel subsystems are actually being used and invoked. And if you're curious about this, there is a white paper, which I'll go into a little bit later, that's out there now. And we also upstreamed this methodology to the kernel itself, because once we started talking about it at conferences, both Shua and Shapali, there is interest. And so it was written up and contributed upstream, which is, ideally where we want this type of information to reside and be able to be useful to other people working with the kernel. And so, we basically did the tracing with strace, and we gathered both the static and dynamic module information. And then the tools employed were using the dump tool, the kernel tracing, lsmod, and some various scripts that were available. So if you're curious to read more about what we've done, if you go to the docskernel.org, there's an admin guide now for people using the kernel, as opposed to developers creating the kernel. And there's a workload tracing section. And so hopefully more people will try to work with this type of methodology for tracing applications with Linux and start to, help refine this further. But we have a starting point that's up there and upstream in the kernel now. Other things that we've happening is, as you can see, we've completed our iterations of the first and second level analysis based on feedback, and we filled in all the tables with the unsafe control actions, requirements, reverse, derived requirements from them, and looking at the loss scenarios for both level 1 and level 2. And the results have been published into a GitHub repo, and this link will basically take you to there. We did all our work initially on a spreadsheet, and then we decided to publish it out in YAML such that it's machine readable by other tools, and other tools can start to consume it and potentially reason about it in future. At least this is the direction we'd like to try to see if we can get a methodology to emerge. The tool for converting that STP analysis spreadsheet into a machine readable form was published as well. And so if other people want to experiment with that, they're welcome to. And again, feedback is very much welcome. But what we wanted to try to do is start to make it possible for this type of thing to be consumed. The other things that we've been working on is obviously this methodology I just finished mentioning. And, tracing the kernel and trying to get the components for L3. So we're sort of getting to a partial architecture of the kernel. However, some of the stuff is starting to head towards where the architecture working group is going. So we need to probably be getting together with them and figuring out, okay, how do we actually partition, and where do we start, talking about, breaking things down for further levels of analysis. And there was a white paper that was put out on, discovering the kernel subsystems used by workload that others can reuse, and goes into the details. And Stewart and Shefali pulled that together for us and published it out there. And then the other thing that would happen later in this last year, Shefali's been working with Milan, and they basically gotten the OpenAPS running on a virtual machine. And thank you very much to the tooling group for helping us get that all going, because that enables a few more pieces of analysis for us. So looking forward to next year, this is the work in progress diagram that we were looking at from the level 3 with what's happening from inside the kernel. And what we were sort of coming out from the various IOCTL calls and traces and so forth to figure out what was actually being pulled in from device drivers, perspective, and system call interfaces and so forth. So talking to the architecture working group and having some sort of, what makes sense where, something that we need to, figure out and get partitioned. We are actually trying to see if we can get OpenAPS to actually build with Yocto, so that we can take advantage of the meta-ELISA work and also generate out SBOMs for this. We'd like to actually start looking at how the SBOM analysis would play into this, and then taking some of the requirements that we've got and looking at creating requirement SBOMs and seeing if we can get everything hooked up to show an example that's out in the open for everyone. We're going to be working towards see if we can get a white paper out about the level 1 and level 2 analysis. We've got a lot of overview docs that have been scattered over the years, and pulling together a coherent full white paper with this use case, I think will be useful to others in terms of how it can be approached. And then the other thing we're looking at is seeing if we can find some, additional medical devices and people who want to study them with us, and try to see if we can apply this methodology to other devices where we can get enough information to be effective at doing the analysis. So if anyone knows of one, please feel free to connect us up with them, or encourage them to join in on the calls and propose. I know the Loop folk are also open. If we do not find someone who's willing to come in and interact with us, we might start looking at that, since it's close to the OpenAPS we've done already, and to see where the differences are might be illuminating. And so that's kind of what we're looking at right now, going on for 2024. And so if anyone's interested in help, again, first step is to sign up to the mail list, and then, feel free to come and show up at some of the meetings. We've got some people, some volunteers who are wanting to work on improving our onboarding experience. into this group. And so hopefully it'll get better this year as well. And I think that's just about it. Does anyone have any questions for me?
Thanks, Kate. I actually was wondered, so there's the open APS and you run scripting and it has certain, of course, safety responsibility, but in the automotive worker, we heavily rely on watchdogs. So is the external system insulin pump or so still behaving as a watchdog, or how you have to treat this? So because you need to make sure that you don't do something or do an overdose or so.
Right. So the reason that you're not overdosing is you're using the insulin delivery is the basal dose, and there is an element of human oversight as opposed to mechanical oversight that's already built into the system as such. What it's doing mostly is helping calculate the doses and so forth. But the insulin pump is an FDA device, as is the glucose monitor. And these are both FDA devices meant to be operated with the human making the judgment call in the loop effectively. And what this is doing is providing an assist to the human to help make sure to help factor in what's happening, and also, quite frankly, to determine history of the person over time and understand, okay, how how is a person's body reacting to certain stimuli, and helping to calibrate things to be a bit more intelligent, as opposed to waking up from an insulin alarm at 4 a.m. from your glucose monitor and then trying to figure out what you need to do when you're half asleep. So this is, again, meant as an assist and to stop those spikes potentially from happening in the first place.
And the second question which I would have is, I saw you mentioned Yocto also as one part of the roadmap. What's the main driver of porting the whole OpenAPS to Yocto? What was your consideration to say, well, that's a good idea?
Yeah, it was moving it over to Yocto to, quite frankly, Yocto is an easy way of generating out the S-bombs. And none of the other systems seem to have that. And we wanted to start looking at hooking in the system bill of materials and pulling together the requirements into that format as well. There's Nicole, who's also a regular member of the group, is quite interested in that aspect. And so pulling the requirements and being able to hook it to the code, and also having the code in S-bombs seems like a way of starting to show how we can work with systems as a whole. And do
Do you
some
still
things
look
that
for a volunteer to
very
do the
much,
Yocto work, start on it?
very much so. Shefali's working on it, but she's not expert, and she could certainly use someone to help hands. So, like I say, help is definitely welcome. And if anyone is very engaged with Yocto and wants to help us refine it, however we're porting it over, that would be very much welcome.
Yeah. We should also check in the other communities to find if there's someone fits in there. So like also with an AGL, even if it's automotive grade, there's a bunch of people very active in the Yocto scope, and I guess it will be a piece of cake for them to just get this piece of libraries and so on ported to something else, and then may even give synergies between other work groups as well.
And showing how the port, so basically documenting what factors are important with porting it into Yocto is potentially interesting to others as well. And certainly whatever we do, if we can get some people from the Yocto community to review it and tell us where we've done things wrong, that's good too.
Cool. Hey.